predictions, y hat. So now I'm going to go into my L3 and do the special thing that we talked about before. So here's my calculator. And you're going to want to write the instructions for this. You're going to go into Stat. Enter. You're going to arrow over and up to L3. And then hit Enter. You're going to clear out that stuff, so hit the clear button. Hopefully you're writing these instructions down. And then you're going to say, I want to use my equation that I just typed in. So now you go to vars, and then yvars, and then enter, and then enter. And what this has done is it's said that my L3, my list number 3, is going to be using the prediction equation. And the things that I'm going to plug into that prediction equation are the things from list number 1. So I do parentheses, list number 1, parentheses, and then enter. And when you do that, everything in here, in list number 3, are the y values that you thought you should get. Now you don't have to use the calculator like I did to get these. You can do each one by hand. So now in list 3 we have all of our predictions. Or in other words, what we thought we would see based on our prediction line. To find the residuals that you're going to put in, you are now going to go to list number 4. You're going to arrow up, hit clear, and these are your residuals. So remember, residuals are L2, which are your actual y values, minus L3. So second number 2 minus second number 3. And then hit enter. L2 minus L3. That was in our notes, and it's also being recorded. L4 is all of our residuals. L4 is all of our residuals. Back in our notes, what that's saying is all of this stuff here, I am putting into L4. These are my residuals. Now, if you want this root mean squared error, from the previous page, if you remember, that was the square root of the E thing, which means sum, y minus y hat, which we now have in list number 4, but we want to square it. And then that's going to be divided by the number of things minus 2. So let's go into L5 and put L4 squared. This stuff right here, I'm going to put into L5. So let's go to L5. Arrow down. Arrow up, I mean. Hit clear. So L5, arrow up, hit clear. It's now empty. I'm going to square everything in L4. So I go second, 4, and then I square it and hit enter. All of this information in L5 now was every single residual that we found squared. I could, if I wanted to, add up all of L5 by hand and find the sum of my residuals squared, which is the top part of the root mean squared error stuff. Or I can let my calculator do it for me. So to do that, am I going too fast? I go stat, don't forget to write it down, calc, enter, and I want to do this for list number 5. So I go second, number 5, because I want to create these one variable statistics for list number 5, and then I hit enter. And what this is doing is it's saying, hey, look at list number 5 and do a bunch of junk for me. And all I really care about is the E. I want the sum of that stuff. So the sum was 3.78 roughly, or 3.781, if you want to go to 3 decimals. I require at least 2, but if you want to go to 3, that's fine. So now back in my notes, the EX, which was the sum of that list, I write down, and I say that this square root is really like saying the square root of, and the number that we got when we add that all up was 3.781 over n minus 2. And so the n is the number of data items that I have. So I have to look back and see how many data items do I have. No, not even close. I have 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I go back into my square root, and I use a 9. So this is how many data items. And in my calculator, instead of going 9 minus 2 on the bottom of the square root, what I'm going to do is I'm going to go to my calculator, and I'm going to hit clear here, and I'm going to take the square root of 3.781 divided by 7 and hit enter, because 9 minus 2 is 7. And this number, this 0.735 roughly, is called the root mean squared error. This means on average how far am I off? So I write that number down, 0.735, and that's my root mean squared error. And what this is saying in the real world, what does this mean? Is if I used my prediction equation for the height of a boy, I should be within 0.735, what was our measurements? Centimeters. Plus or minus. So I might be a little bit more than the height of the boy, I might be a little bit less than the height of the boy, but I'm within a centimeter. So that's a pretty good prediction. That's why we use the regression line. And again, we're not using this median line, so cross that off and write down the word regression. And it says, if we use this regression line to find the average height or mean height of a boy's age at 15, what range would you predict? So first of all, you probably should know at age 15 what you would think the height should be. So in order to figure that out, we have our prediction line from up above. So our prediction line, way back up here, was at 5.728x plus 81.434. So I know that if I want to figure that out, I use my y hat, and I'm going to have 5.728 times whatever age they're talking about plus 81.434. And the number they want me to plug in is the one that they were talking about, the 15. So I shove in the 15. So I grab my calculator and I just type that in, 5.728 times 15 plus 81.434. And the number that I get is that I would expect to see 167.354 centimeters. And so, did I get that wrong?
I was just thinking of another way to do it.
Okay, hang on. Then I know that because I can be within 0.735, if I would have taken that number and added 0.735, my far range to the right, that is 168.089 centimeters. And if I would have taken the 167.354 and subtracted off 0.735, because remember I could be above or below, I would get 166.619 centimeters. So the range would be between these two brown numbers, because my prediction said in light blue I'm at 167 and some odd centimeters. But the truth is, I know from the root mean squared error I could be off, so I could be above that amount by 0.735 or below that amount by 0.735.